knowledge what questions this talk will help answer. Okay, so we have been listening about generative AI since the event started, right? And it's been awesome. But, what I think is, let's take a step back. And in order to actually understand where we are headed with the growth of generative AI, isn't it essential to understand how a machine learning project actually works end to end, right? So, addressing that, let's take a scenario. We all collectively have an amazing AI startup idea or a project idea. Now, there are just two things possible. When we talk about a startup idea, there are two cases. A, your idea is very generalized. For example, maybe a OCR use case or a text summarization use case. For an idea like this, you can use any publicly available data. But what would you do? Would you just look at the latest state-of-the-art models, use an API plugin, and done? Wouldn't it cost you, right? And would you actually understand what are you spending on? Because all of these complex algorithms are kind of like black boxes. You don't actually understand what's going on underneath. So, should you spend that much? If you are a startup, you must have limited finances as well. So, should you spend on something that you don't understand? You should not. So there are a lot of things that go in the process of finalizing a project, which I will refer to during the talk. And second case, you have, for example, you have a really unique or specific idea. For that, you can't actually use any publicly available data. For an instance, let's say I want to predict when the minds of all the people present in the room will start wandering and fantasizing about lunch after my session, right? So for that, I would need to collect specific data, label it myself, creating into training data set, and then go ahead with the other process that comes with the model selection and development, etc. And on an even larger scale, this can be really frustrating if you're just starting out for a project or a startup. You have to manually collect everything. You have to understand what's going on, which is not mostly the cases, because not all AI experts start the startup idea. It could be a business person as well. So what would you do? Would you just give up out of frustration? Right? That is also not an option. But for even just to label your manually collected data, if you go with hand labeling, which is the convenient option, it is really expensive, and I will explain why. So that is also not an option, because you have limited finances and you need to save it for the later stuff, marketing, deployment, infrastructure, etc. So what should you do in that case? That is also one of the questions that I will help you answer. So let's start brainstorming our AI startup idea. So first things first we need to frame our machine learning problem correctly, right? To decide which ML model we need to use to solve our problem, first we need to frame our problem into something that ML can solve in the first place, right? So we all know that supervised learning is most common use cases, regression and classification. But did you take a second and think that how a regression model can be easily converted into a classification problem and vice versa? I'll give you an example. And I will also explain later why this matters. So let's buy a house. Consider, house prediction is a classically regression use case. Everybody would agree here, right? But what if I quantize the house prices into buckets, such as under 100,000, then in the range of 100 to 200, 200 to 400, things like that. Now it has easily become a classification problem. I just have to classify which bucket it falls into, true or false. So we have converted a regression into a classification problem. Now let's fight the evil lords, or classic email spam classification problem. So again, this is a famously classification problem, but how we can turn it into a regression problem. So what we can do is to identify if an email is spam or not. I can just have the model make my target variable into a range of 0 to 1. And I can set a threshold that if my output is more than 0.5, then this email is spam, otherwise it's not spam. So this is how we converted a classification problem into a regression problem. But what if I have more choices? So I have many classes. It's not just email or not, but I have, so I will give you example for this situation. So let's assume that you are working at Amazon and you have thousands of products to classify. You need at least, so this is a machine learning thumb of rule, that you need at least 100 examples per class in your data set. So let's assume that you are classifying 1,000 products. So immediately the math is like 100,000 examples at least you need to work with. But of course some products will be rare. For example, if you are selling a painting of some artist, it's and if the artist just paints like once 5 years or something like that, then where will you get 100 examples for something like that, right? So this is an example of how data collection can be a pain in multi-class classification cases. So what you would do? So this is what we do in these cases. It's called hierarchical classification. So what we do is we divide our data into large groups. Let's say I will divide products into kitchen appliances, office supplies, beauty, fashion, etc. And then I will use another model. After the first model classifies, okay, this is an office supply item, then I will use another model to specifically identify which product it's talking about. Is it a pen stand or is it a paperweight, whatever, right? But in all these cases that we talked about, binary and multi-class both deal with just one label. Is it a pen stand or not? Is it a paperweight or not? Is the house price belong to this bucket or not? So it's basically one label, one target label. But what if you have a situation where example can belong to multiple labels? Now let me give you an example of this as well. Imagine you are a machine learning engineer at Medium and you need to classify the articles into different categories like education, lifestyle, tech, finance, entertainment, right? Now an article can belong to education and tech both. There are multiple articles about edtech. So what would you do and how would you classify this particular article? So in this situation, first of all, we have been solving problems left and right for last 5-10 minutes, so you guys rule. But okay, coming back to the question, what would we do in this kind of situation? So there are two options. A, we treat it as a multi-class classification problem. So usually in supervised learning, we encode our target labels into 0, 1, true, false, whatever, right? So instead of just targeting to like 0, just one for one label, there could be, we could put one for multiple labels and treat it as a multiple classification problem. Or we can do the crazy thing and we put multiple binary classification models. So for example, we train 5 different models. Each will identify if it's education or not, life cycle or not, tech or not, finance or not, entertainment or not. And then we combine the outputs and we classify. But why would I call this particular solution crazy is that you could have 1,000 categories and this is not just a research project. You are deploying this. It's working in production. People are using it. So how immensely difficult it would be to maintain these models, retrain these models, and monitor their data and model drifts and things like that. Right? So I got you through all these situations to make you realize that this is why framing machine learning your machine learning problem correctly, why does it matter, and why you should spend enough time on it and put some critical thinking into it before moving on to model selection or model development. Okay, so we framed our machine learning problem. Now moving on to organizing our objectives for our project. So we should always decouple objectives. So like make it think step by step like we do in chain of thought prompting. If you know, you know. So when solving a problem, you might have multiple objectives in mind. Again, let's take another example. We are creating a social media application and we are building a system to rank items on users' news feed. What's your goal? User engagement, of course. That's what the money comes from. But you also need some objectives to put into place before you go ahead with user engagement. So the common things we do is we don't want we don't want to spam our users, so we will filter out spam. We will filter out NSFW content because of multiple regulations in place. And then finally, we will rank posts by engagement, that how likely users will click on it at the end. But you soon realize that maximum user engagement can also mean Satan's minions are at work, because extreme posts tend to get more engagement usually. And won't you prefer a more wholesome feed for your users, like those cat gifs I have put all over my PPT? So what would you do? So instead of what's your goal, now you update your goal to be what should be your goal. So you need to now maximize user engagement. That goal is there, but while you also need to minimize the spread of extreme views and misinformation. So you add two new things. You filter out misinformation, and you rank posts by quality. But isn't this a paradox? Because posts that gain maximum engagement are of extreme views, and extreme view posts are not necessarily of good quality. They are almost 90% of times of less quality, right? And but you also have to rank posts by quality. Now, how will you create a model like that? When you sit and think about it, how would you teach this to a model? So this is where our friend loss function comes into the picture. So loss function is when models find the right way to be wrong. So what would you do is, in your loss function, you will optimize on quality loss as well as engagement loss in order to balance and get your objective to have a wholesome feed for your users. So for those who don't, I know most of us are professionals, but just to explain, quality loss is like real value and difference between real and predicted value. Okay, so this is how we balance. But the thing is, if engagement is very high for one post and quality is very low, then in order to balance it, you would have to increase the value of alpha and decrease the value of beta, and you can't do it constantly once you have uploaded the model or deployed the model to production. So this one is a better solution. You create two different models. One will optimize on engagement and one will optimize on quality, and you can take weighted average, which are combined scores, whatever, and you will be good to go. So this is how we do critical thinking when it comes to machine learning projects and gain our objectives while keeping things sane on our applications. Now, we have framed our problem, we have decided our objectives, and we have found a way to achieve them. Now, what we come to is data. So, there are a lot of things to talk about in data. Data sources, data formats, data relational models, document models. All this, you can just, these are very common topics that you can look up and learn about. What I would like to, again, do is just give you a food for thought in this situation, that why data modeling matters and why you, so let's take an example. So of course, data modeling is how data should be represented. Call it schema, call it blueprint, call it skeleton. Okay. So let's take data model of a car. You have all kinds of data about a car. Their maker, color, price, owner, license plate, owner's registered address, owner's contact, etc., etc. Now, how should you model this data that you have to cater to your objective or your problem statement? So if I just create a data model of the car's maker, color, and price, what can I do with it? I can create an application that could be used by someone who wants to buy a car. That is kind of information that would benefit this type of person. But what if I I model it in a way that I take owner, who is the owner, their license plate and their registered address. This kind of data benefits someone, you can be used by the police to track down the criminals. So this is why how you model your data can impact your objectives and even inspire you in ways. If you have any kind of data and you want to make something out of it, just sit and how would you model it in a way that you can get something out of it, or you can create something for someone or even yourself. So as this model is saying here, modeling matters. So okay, now where does, we have identified our data source, But where does training data actually come from? So Kaggle, well, that too, but not really. So how do you actually create a training data if you want to for your startup? So there are very specific techniques to obtain or create good training data. So it's called sampling. There are two main types of sampling. So my objective is not to information dump on you, but give you the right terms to Google later and deep dive later, because this is all really useful stuff. So two things, non-probability sampling and random sampling. So let's look at non-probability sampling and how we can use it to create training data. So you have some data source. So if you are going with non-probability sampling, there are 4 ways. First is convenience sampling, and as the name sounds, data samples are just, you get data samples based on just their availability. If it's available to you publicly or whichever way it's accessible to you, and you are using it, so you are what you are doing is you are doing convenience sampling. And the other one is snowball sampling. So what this means is, I will give you an example for this. So technically what you can say is future samples are selected based on existing samples, but to break it down, you need to scrape Amazon product seller pages for your project, right? But obviously you don't work at Amazon and you don't have access to that database. So what will you do? You will select a bunch of seller pages in the start, scrape them, and then to find more pages, what you can do is go see who these pages that you are scraping are following other pages, and then go to those pages and scrape them, and so on and so forth. So this is one way of gaining training data, and that's called snowball sampling. Then there is judgment sampling. Just as it sounds, you hire experts to decide what samples to include, right? And it does not necessarily have to be on a game of rock, paper, scissors. So another one is quota sampling. So in this particular case, this is a pretty common way of creating training data. So what you do is you select samples based on quotas for certain slices of data without any randomization. So again, to break it down, let's say that you are taking a consensus of age distribution at our event of people. So what you will decide is, I will, regardless of what actual age distribution is and what age group is present here more, you will decide a quota for each age group prior. So I will I will have 10 samples for people from 18 to 24. Then I will have 10 samples for 25 to 35, and I will have 10 samples for 36 and onwards. So regardless of if people from 18 to 24 are present more here, you would pre-decide a quota for the data you want to collect. So that is quota sampling. So okay, this is one way, but disclaimer, training data generated using non-probability sampling does not represent real-world data, as I just gave you an example about the age distribution thing. Because as a person is doing it, there is lots of selection bias. Okay, I could be interested in the age group of 18 to, for example, 35 to 45, because those could be people who are founders of companies, and I want to maybe find an opportunity at their organization or something. So there could be selection bias when I'm creating this particular kind of training data. Then it's theoretically not a good idea to use it for machine learning use cases, but it's still very widely used, because who doesn't like convenience? Two biggest examples are language models and self-driving cars. So let's take a look. So language models, right? So that data was collected using non-probability sampling. So these are obviously not trained with data that is representative of all possible text in the world, but it is trained on data that can be easily collected. Wikipedia, Common Crawl, Reddit. This data does not represent all possible text in all possible scenarios. So it's not trained on real world data as much as it is the terms are pushed around a lot. So language models are trained on non-probability sampling. And the other one is self-driving cars. So initially, the training data, when the hype around self-driving cars started, Majorly the training data came from these two areas, Phoenix, Arizona, because they have some loose lax regulations which allow people to collect that data. And Bay Area, California, because most companies that build self-driving cars are based there. So again, convenience, right? So, but the thing is, both of these places have majorly sunny weather around the year. So, obviously, training data for self-driving cars in sunny weather was way more than rainy or snowy weather, which made things very risky, even though at the time, whatever the state-of-the-art models were showing, they don't actually discuss about the evaluation of those. If they evaluated those models, we would understand that it was very risky because of the bias with the weather. So these are two examples of non-probability sampling. Now coming to the random sampling. So this is, so that was non-probability. This is based on probability distribution in the data. So what you do is, let's imagine if you have an Excel file, let's call it a population, and let's call a row a sample to make things easy, because these are terms from statistics. So you give all samples in the population equal probabilities of being selected. Okay, so that is random sampling. But let's assume that I have credit card fraud detection data. So even if we take a survey in this room, how many people are affected by credit card fraud? It could be barely 1 or 2, right? If people are getting victimized by credit card fraud left and right, then banks will be bankrupted. So out of 100 people, if 5 people are affected, that is class imbalance. You don't have enough examples of the negative class to predict well for, so it does not generalize well, and probably model will overfit more on the cases where people were not affected by credit card fraud. So in order to solve this, this is the saner method. It's called stratified random sampling. So it is same thing, but what we do is we make groups first, so no class is left out. So I will make a group where people were not affected by credit card fraud, and I will make a group of the victims. And I will say I need 50% from this class and this class as well. So we solve the kind of class this way as well. So class imbalance is usually solved using data augmentation and adding more training data. But this is also one way to do it, which is not more talked about. So I'm just introducing to you. If you are interested, you can dive deep in on it later. Okay, so we framed our problem, we decoupled our objectives, then we collected our training data. Now what we need to do is we need to label our data in order to make it ready for model development. But there are two ways, hand labels, and what to do if hand labeling is not possible, which is my favorite part of the talk. So hand labels. So hand label is you just hiring someone or you labeling the data yourself. But what if you have, like, let's say just a lot of data, then if you, let's take this example, okay? So you want to label email spam classification data. This is a pretty easy problem, so you can just go to any crowdsourcing platform and train the people in just like 15 minutes and teach them what you're looking for, and they will label your data. But what if you have data like maybe a data set of chest x-rays? In this case, you will need to find board certified radiologist, and for experts like those, the time is limited and expensive. So this is one of the reasons hand labels are not recommended if you have a lot of data and you are just starting out as a project or a startup or either. And also, since humans are doing it, it's slow and it's set to data privacy, obviously, because you're letting other people take a look at your data in order to label it. So these are the 3 cons of hand labels. So what will you do? So just ditch the idea altogether. what else we can do is we have other 4 ways. We have weak supervision, we have semi-supervision, we have transfer learning, and we have one thing called active learning. I won't go through all the 4 of those, but let's take a look at weak supervision and semi-supervision. So let's zoom in. So how many of you have heard of Snorkel? Okay. Yeah, so 2-3 people. Good. So this is a really great tool which was developed by Stanford AI Lab very recently, actually less than 5 years, I think. So as it says, Snorkel it was created for rapid training data creation with weak supervision. Now what is weak supervision? As I said, my talk is oversimplified. I just want to give you the right terms so you can study the right things later on your own time. So I will go through it in a way that we all understand. So before machine learning was invented, what people relied on? Common sense, right? Heuristics. For example, if someone said like, I will sell you 2 apples for 4 rupees, and if you needed 4 apples, then what would you do? You will assume they will take 8 rupees from you. Logics like that, heuristics like that. So we will use the same heuristics to label our data. And so how would we do that? Let's see. So let's say that you are a customer service agent, and you want to understand which complaints to prioritize first and which complaints to prioritize later. So the keywords you would if you're manually looking at the comments or complaints, you will look at keywords like, okay, my order is past their delivery date, or my order is damaged, and you would want to prioritize those over, I just didn't like the guy who delivered, he was creepy or whatever, right? So, okay, so what we did was we looked for keywords, and we can teach the same thing. So Snorkel uses this thing called labeling functions, where you can give it a keyword to look for in the text, and if it finds those keywords, it will label it whatever you want to label it. Example, like return high priority if you see delay. But this is not all it can do. It can also use regular expressions. If you are looking, even if there are typos, you can solve it and let it label itself using providing proper regular expressions. Then you can do database lookup. For example, you are doing this for a healthcare data, and you want to see if I have pneumonia and maybe a fever or a headache, all both together, what is the possibility, what I can be coming down with. So you would give it a database, or let's say knowledge base per se, and it would use those keywords, and it would look up into the data itself, and then it would label it whatever the answer is, like that. So this sounds doable, right? But that's not it. Weak supervision is a lifesaver when you have strict data privacy concerns. And if you're just starting out, and if you're, let's say, working for a client, and you are not that established for them to trust you or whatever, so they would be very hesitant to give you data to go ahead with your project. So you can propose this, because you just need to get permission for a very small subset of their data, and you can train the Snorkel tool on that data, and it would understand what to do, and then it will label the rest of the data without having to actually look at the data. So it is really a lifesaver when you have strict data privacy concerns as well. So this is a diagram. This was the example. So this is from the original research paper of Snorkel. So this is the unlabeled data, and here they have domain heuristics are provided that chemicals of type A should be harmless, this and that, and magnesium, so what kind of chemical it is, etc., etc. So these are the heuristics given by domain experts, of course, because it's a medical use case, and some patterns to look for, and some external knowledge bases, etc. So both are provided together. And using the labeling function, and of course we need context hierarchy, how it will identify keywords if it doesn't know what is entity, named entity recognition, all the NLP things, right? So this is context hierarchy and labeling functions, and they both work together to give us a Generative model, what it is doing is, it is labeling the unlabeled data, that it is generating labels, that's why it's called generative model. And at the end, we get our probabilistic training data with the discriminative model. So this is a very high overview of how Snorkel works. So this is one of the new things, I mean, not new, but let's talk about things I wanted to discuss with you today. Then the other technique is called semi-supervision. So, like, just to like get your attention, this is the way the data for the training data for all the large language models was labeled. So this is so this was the technique that they went for, and it is, you can also call it like self-training or something like that. So there are two ways to do this. First is, to simply put, you just train a model on some chunk of labeled data, and the model will understand how to label the data, and it will label the rest for you. This is one way to just, in layman terms. And the second is, teach your model that data samples that are similar, that have similar characteristics have same labels. The same thing when we do with, for example, k nearest neighbor thing, right? So if these are like, if their embedding is near to these points, so this can be also belong to the same class, the same logic. So biggest example of it is web content classification. So many search engines, including Google, uses a semi-supervised learning model to label and rank web pages in their search result. How they might do this is, let's say, if they're looking for web pages and they find the terms, let's say hashtags, AI is on one article, then there is big data on another article, and there is computer science in both the articles of AI and big data. So how it will understand is, AI also belongs to computer science and big data also belongs to computer science. So this is how it can relate, and this is, it sounds very simple, but yeah, it works really well even on very, very large scales like the Google search engine. So these are the two ways. Now, I got you through framing your problem, decoupling your objectives, then getting and creating training data and labeling it. Now what we move to is the other rest of the part, model selection, development, deployment. And I will get you through a quick hands-on because we have like 8 minutes to go. So I will be a little quick, but feel free to ask me any questions later after the session. So how many of you have heard about PyCaret as a library? Oh, awesome, okay. And DagsHub? Okay, okay, cool. So I'm sure MLFlow most of people have heard here, but yeah, I thought PyCaret and DagsHub could be the ones, and I was right. Good. So I'm a good machine learning engineer, I can predict well. Anyways, yeah. So, okay, starting with PyCaret, for those of you who don't know, it's a low-code machine learning library. So, it's not a no-code. So, it's not a tool like on some automated tool on Vertex AI where you just click things and things happen. But it's a low-code library, so you don't need to know much or need to know how to code much, but it will do the things for you. And what things it can do, let's discuss. So I'll get to MLFlow and DagsHub when their part comes into the picture. Right now, let's focus on PyCaret. So here I have taken some open source data on customer churn. What is customer churn is, imagine you are a telecommunication company like, let's say, Jio or Airtel, okay? So what will happen is, if your customer service or your speed or whatever, for whatever reasons, if customer is not satisfied, they can ditch you and go to Airtel. So what they are doing is, they are this term is called customer churn. They are leaving your company and joining any other. So this churn term is true for any subscription-based services, including Netflix, Disney Plus, etc., etc. So okay, so we have this churn data, and let's take a look at the data. Okay, so just inform me in the last 5 minutes, so I will end accordingly. Okay, so customer ID, gender, object, like string, senior citizen is that is the age one, so it's integer. This looks fine, but let's look at total charges, right? So total charges, which should be float or integer, is object here, which is an issue, and how can we rectify it? And let's also see if our data has, so now it shows that there are no null values, but it's not null because the string format accepts null value as a string. So that's the issue we have, and just because we sat and looked at the data, now we can rectify it. So now we rectify our data type of total charges from object to float. Now if we check, we can see that there are 11 null values actually present there. So now we use PyCaret for classification. So it's like 0, 1, true, false thing. Customer is churning or not churning, right? So in PyCaret or classification, all I need to do is, after installing it, pip install PyCaret. From PyCaret or classification, import everything, star. And this is all it takes, a setup function, right? So this will do all the pre-processing for you, including imputation of these null values. So all the feature engineering stuff, which I wanted to do a deep dive on that as well, but we don't have enough time. So I'm naming this experiment, and I'm going through it. And so it shows it did pre-process our data. It identified itself what to do. It did imputation, for numeric imputation. It did, it used the mean, median mode, so that one, average one. So these are the other details that you can look at it. Now we are doing model selection. So if you, in PyCaret, we have this function called compare models. It will compare all possible models for you, and it will highlight the models with the highest accuracy, highest recall, highest F1 score, all these things. Now we can see that the ADA Boost classifier is the best one for us. So this is our pipeline. I'm saving this pipeline. I'm calling it MLOps demo pipeline. And there is this excellent feature in scikit-learn library called setConfig, and you set it display to diagram, and we can see our library in action. So it shows that it did some label encoding here. So let's see what it did. So in detail, right? Sorry, simple imputation. So this is for numerical imputation. It used this function simple imputer in the scikit-learn library, and all these details. So this is for the categorical features. So these are our categorical features, and this is all the feature engineering that it did on that. So you can take a look in detail on this. But okay, this is all I did in my Jupyter notebook, and I can't actually put this into production, right? So that is why we talk about MLOps, deployment, monitoring, everything. So that is why, that is how MLFlow comes in the picture. So it's a library that you need for experiment tracking, and so we are less on time, so I'm just speeding up. So it's a model registry and scaling, so you can track all your experiments and register a model online and scale. It's vendor agnostic, doesn't matter which cloud you are going to deploy MLFlow on, and you can scale your model. So okay, now we come to the other thing is DagsHub. So it's just, you can imagine DagsHub as GitHub for ML. So what we need actually, why we can't just use GitHub, because unlike other cases like front end or web or whatever, we don't just need to version our code, but we also need to version our models and data. So DagsHub, what does is, this DVC is data version control. This is a great service. So it provides this, and it versions our data for us, as well as it versions our models, and it works great. So if you want to see it in action, I configured MLFlow to follow my DagsHub tracking URI, which you can see here. So instead of doing it in my local Jupyter notebook, now I have it on DagsHub. And this is the thing you saw in notebook, this one, where it is comparing all the models. You can see here as experiments. So it experimented with like 15 different models. So you can just click on it, and you can see, okay, what parameters this model had, what was the matrix of the output. You can, so this is a model registry, and if you like this model, then you can just register model, and it will you can save it in the model, and you can even change the stages. So for example, the stage of this model is production. things like that. So there are a lot of things to talk about, but this is how it would work. Okay, so yeah, this was it. I was trying to get you through a whole process of how we should generally approach machine learning projects. If you have any more questions, you can come and talk to me in the break after this. Thank you.